Hello, this is Mr. Stansbury. I'm going to take you through the 19B notes on derivatives. Okay. After this, you should be able to say, I understand what dy over dx stands for, and also I can find the derivative of simple functions. Okay. So for this here, we're actually going to do a worksheet, the 19B derivatives worksheet. Okay. So first thing, before we even get into this worksheet, I want to explain what dy over dx means. Okay. If you remember in the last section, we were talking about rates of change. What dy over dx is really the d basically is it stands for the derivative of y with respect to the derivative of x, which in more simple terms means the change in y over the change in x. So really, the change in y over the change in x really it's basically the slope of a curved line. Now you're like, wait, you can't find the slope of a curved line. But again, if you'll remember, what our derivative is, or the slope of that line, is basically, if I was trying to find the slope of this point right here, like the change at this exact point, that instantaneous rate of change that we were talking about, it's basically going to be the change in x over the change in y. Or again, it's going to basically just be the slope of the tangent line at that point. Okay, so that's what dy over dx is. Derivative of y with respect to the derivative of x. But again, in simple terms, it's simply the slope of the tangent line at that exact point. Okay, so what we're going to do is we're going to find some tangents to those points. To some points here, sorry. So it says here, number one, carefully draw tangents to each curve at 0, plus and minus 1, plus and minus 2, and plus and minus 3. Okay, so let's take a look at that. Okay, so here's our graph. I've just got a little bit more interactive graph here. So we're going to draw the tangents to each curve here. Okay, so the tangent to the curve at 0 is this point right here. So the tangent is simply just going to be this flat line right here. Okay. Okay, so here's that right there. There's the tangent to the curve at 0. And then we're also going to do plus and minus 1, plus and minus 2, plus and minus 3. So let's see. Let's just do positive 1, 2, and 3 first. So here is this point right here. So we want to come up with the slope that's as tangent, make a tangent to that as close as we can. So basically what you're going to do is you just want to get a straight edge and try to make it just barely touch that point right there. Okay, and so I did that ahead of time. And here is the tangent line to this, to the y equals x squared here at 1. So there's our tangent line. Okay, all right, and then we're going to do the same thing for 2 and 3. So here's 2. So we want to draw a tangent line there. So it's going to look again something kind of like that. I did that ahead of time, and there's our tangent line at 2. And then the same thing for 3, tangent line at 3. Notice it's getting steeper and steeper each time. Okay, so there's our tangent lines for for 0, 1, 2, and 3. Okay, now we're going to go back and figure out the same tangent lines for negative 1, 2, and 3. So here is negative 1. There's our tangent line at negative 1. Here's our tangent line at negative 2 right here. And then here's our tangent line at negative 3. So it does look kind of like a big mess there. It is going to actually make a little bit more sense here in a minute. But those are all of our tangent lines. Okay. So now what we're going to do is we're going to use the grid paper, okay, our graphs here, to approximate gradients of these tangents. So what we're going to do is we're going to try to find the slope of each of these. Okay, so the slope at 0, that one's pretty nice and easy. That slope there is just simply 0, right? Let's make that nicer. All right, so there's our slope. Purple, I guess we'll have to do. Right there. And then, let's see, let's see our slope here at 1. And again, notice the scale here. This is 1. Every vertical line here is 1, and every horizontal line is 5 units. Okay, so what we want to do here is we want to just start to find some nice points. So here's a nice point at 3, 5. And then let's see, here's another nice point at -2, -5. Okay, so we just want to find the slope between those 2 points. So we've got, again, -2, 5, and then we have 3, 5. So let's do that over here. So we got -2, 5, and 3, 5. Oh, sorry, I think that was -2, -5. So we go 5 minus -5 over 3 minus -2. So that's 10/5, which is 2. So at 1, our slope is 2. All right. For 2 here, let's get rid of some of these other ones here to make our life a little bit easier. Here's our tangent line at 2. All right. So again, we want to find a couple of nice points. Looks like there's a nice one at, what is that? Looks like 6. Here's a nice one. Here's one at 1, 0. Okay. So let's see, we've got 1, 0, and then we also have another one here at -4, -20. So let's use those. All right. All right. So I went ahead and found the slope between those 2 points. -20 minus 0 over -4 minus 1 gave us -20 over -5, which is 4. All right. So the slope of the tangent line at 2 is 4. So hopefully you're starting to see a little bit of a pattern here. All right, let's look at 3. All right, that was this line here, the tangent line here at 3. So here's a nice point at 4:15. And let's see, another nice line here at -1, -15. So let's find the slope between those two. All right, so went back and calculated that one. We get -15 minus 15 over -1 minus 4 was -30 over -5, which is 6. So slope there is at 6. All right, let's look at the slopes for -1, -2, and -3. All right, so let's find a couple points on this one. Again, here's our tangent line at -1. So it looks like we have -3, 5, and 2, -5. So let's find the slope between those two lines. All right. Okay, so finding the slope between those 2 points, it gives us -2. All right. So again, hopefully you can look at this and see the pattern here, and it does hold up. The slope of this tangent line here is -4, and then the slope of the tangent line at -3 is -6, just like you would expect it to be. Okay, so let's see, we'll do 4 and 5 together, and then I'm going to leave you to do the rest of the worksheet. All right, so plot the points from the table on axes as shown. Okay, so we're just going to basically plot points. So we got -3, -6 is a point. We got -2, -4, so that's about right there. -1 is at -2. 0 is at 0. Oops, there we go. 1 is at 2. 2 is at 4. And 3 is at 6. Okay, so we get this nice straight line here. Okay, and so we plotted the points. So what do we observe from the graph? So we have this here, and we can see that the slope of this line here, so especially if you start from 0, 0 and you go over to 1, 2, so the rise is up 2. So we go up 2 over 1. So we observe from the graph that the equation of all those points is y equals 2x. Okay, so the equation of all these points here, the equation of this y equals x squared, taking the derivative, which is the tangent, the slope of the tangent line, and again I know that's a little overwhelming because we're just reaching into this, but the equation of the line of all those points is y equals 2x. Okay, so what you're going to want to do now is finish off the rest of the worksheet, and then we will talk about our results in class. Okay, so you should now be able to say that you understand what dy over dx stands for, and that you can find the derivative of simple functions, because that's what we just did, is we just found the derivative of this function. Okay, so the derivative of y equals x squared is y equals 2x. Okay, and again we're going to talk about this a little bit tomorrow, a little bit more tomorrow in class. Okay, so if you have any questions at all, please feel free to ask. Okay, thanks.